Hello everyone. Today we are going to see the next topic called as web security. So web security. So nowadays everyone is accessing web, be it for government, for business, for individuals. We also have social media accounts likewise. But even though people are accessing it, the web is not secure. It is vulnerable. It is having a lot of threats, like various attacks are there, and it basically compromises few of the networks security services. So it can compromise the integrity, confidentiality, and authentication. So we know integrity means assurance that the data received is as sent by an authorized entity. So when the message is not received as sent by an authorized entity, we can say the data or message is not having integrity. So confidentiality. So when two people are transmitting the messages, the message uh, should not be disclosed to anyone. So that is called as the confidentiality. Then authentication, assurance that the communicating entity is the one who is claiming that. And also we have threats related to denial of service. So you can have a number of threats in the web. So how can we avoid this is we need some added security mechanism. So before seeing the security mechanism, so now let us look at what do you mean by an attack. So an attack is any action that compromises the security of information owned by an organization. So attacks, we know it can be broadly classified into two types, namely active attacks and passive attacks. So what do you mean by an active attack? Attacks that attempt to alter the system resources or affect the operation is called as an active attack. Whereas passive attack, it will just be monitoring at the background. So there will be no attempt to alter or change any data that is being transmitted between the entities. So that is basically called as passive attack. So now let us see some examples of active attacks. So active attacks could be by modification of the data stream to masquerade of one entity as some other. Okay, replay the previous messages or doing any modifying messages in the transit, and also denial of service also can be classified as a active attack. So what about passive attack? As I already told you, we are not going to modify anything, but we'll just listen at the background. Like we have some passive monitoring tools, like we have the Wireshark and all. We can just monitor the traffic that is going in and out of the network. Likewise, we can just obtain the message contents, or you can just monitor the traffic flows. So passive attacks are basically difficult to detect, and but the advantage is it do not involve any alteration of the data. So that is the one point that we need to understand in passive attacks. So coming to the topic SSL. So SSL stands for your secure socket layer. The idea here is to encrypt and send the data so that no one understands it. It can also be called as the transport layer security service, and both provide a secure transport connection between the applications, that is between a web server and a browser. So SSL was originally developed by Netscape, and version 3 was designed with the public input, and subsequently this became as an internet standard which is called as your TLS. So TLS is your transport layer security. It uses TCP to provide a reliable end-to-end service, and SSL has two layers of protocols. I think you will be familiar with the OSI layer. What do you mean by transport layer? Okay, what do you mean by protocols? Like we have two types of transport layer protocol. One is called TCP and UDP. So TCP is the connection oriented protocol. I think you will be already familiar with that. SSL usage. So why are we going for SSL? So SSL basically authenticate the server to the client. Okay, it can allow the client and the server to select cryptographic algorithms or ciphers that they both support, and it can optionally authenticate the client to the server. So it basically uses public key encryption techniques to generate the shared secret. So public key encryption here means either we can use RSA or um, Diffie-Hellman, etc. So establish an encrypted SSL connection. So Diffie-Hellman is a key exchange protocol we have already seen. So let us see in depth. So what is SSL secure socket layer? It is a secure protocol which runs about TCP/IP and it allows users to encrypt the data and authenticate the servers or vendors' identity securely. So coming to the diagram, so we have the transport layer, and then here SSL fits in between the transport layer and the application layer. So here again they are showing the secure version. So we are having the data link layer, network, transport. So on top of that we are having the session layer, and there we are having the secure socket layer. So we have protocols like HTTP, SMTP and POP3. So we know the HTTP port number is 80, POP3 port number is 110, SMTP port number is 25. So the secure version of these protocols are we having HTTPS, which is using a port number of 443. SMTP is a secure SMTP, so which uses a port number called 465. And we are having the secure POP3. It uses the port number 995. Okay, so these are the secure versions of the existing application layer protocols. So coming to the SSL architecture. So SSL architecture, basically we have the IP layer. IP is nothing but your network. The protocol that works in the network layer is your IP. So we are having TCP is your transport layer protocol. Then we are having a SSL record protocol. So on top of SSL record protocol, we are having the SSL handshake protocol. We are having SSL change ciphersec protocol. Then SSL alert protocol. And then we are having the HTTP. So HTTP is basically where you are having your application layer data. So it will be encrypted and then it will be passed to the bottom layers. So coming to the SSL components. So what do you mean by an SSL handshake protocol? So the first protocol. So SSL handshake protocol, basically it negotiates the security algorithms and parameters. It also takes care of the key exchange. Server authentication will be taken care of the handshake protocol, and optionally, sometimes client authentication will also be done. So coming to the next protocol is called as your SSL change cipherspec protocol, a single message that indicates the end of the SSL handshake. So when the handshake is complete, they pass this change cipherspec protocol message. Then we are having an alert protocol. So it is basically a error messages. Either it can give you two types of warning. So it is of 2 bytes. One is fatal alert, so it can give you some warning. Then we are having the SSL record protocol. So record protocol, basically if you have a message, first it will be fragmented, then compressed, then message authentication and integrity protection will be done. And then on top of that, we are doing the encryption. So now let us understand the two terminologies called as session and connection. So what do you mean by a session and what do you mean by a connection? So what do you mean by a connection? A connection is nothing but it is a transient peer-to-peer communication link. It will be associated with one SSL session. So what do you mean by a session? So an association between a client and the server is called as a session. It will be basically created by the handshake protocol. It will be defining a set of cryptographic parameters and it may be shared by multiple SSL connections. Okay. And SSL session is an association between a client and the server. Sessions are stateful. So the session state includes security algorithms and parameters. A session may include multiple secure connections between the same client and the server. Connections of the same session will be sharing the session state. And sessions are used to avoid expensive negotiation of the new security parameters for each of the connection. So coming to the session and connection state. So first we'll understand what you mean by session state. So a session state basically has few parameters. So first there will be an identifier, session identifier. It is nothing but a byte sequence chosen by the server to identify an active or resumeable session state. Then we are having a peer certificate. We know there is an 500 9 certificate for the peer. So this element of the state may be null. Then we are having the compression method. So the algorithm that is used to compress the data prior to the encryption is called as your compression. Then we are having the chain spec. It specifies the bulk data encryption algorithms such as DES, etc., and also MAC algorithms. It also defines the cryptographic attributes such as the hash size. Then we are having a master secret. A master secret is nothing but a 48-byte secret that is shared between the client and the server. And then we are having another uh, flag which is called as is resumable. A flag indicating whether the session can be used to initiate new connections. So we are having that field also. Next, the connection state includes the following elements. So in the connection states, we having server and client random. So what do you mean by this? From the random itself, we can understand that there will be some random numbers that will be generated. So byte sequences that are chosen by the server and the client for each communication, that is called as the client and server random. Then we are having something called as server write MAC secret. The secret used in the MAC operations on the data written by the server. Okay. Then client write MAC secret means it is a secret used in the MAC operations on the data written by the client. Okay. Then we are having the server write key. So this is nothing but the bulk cipher key for data encrypted by the server and that is decrypted by the client. Likewise, we are having the client write key. It is nothing but the bulk cipher key for data encrypted by the client and decrypted by the server. So we are having something called as an initialization vector. When a block cipher in CBC mode is used, we'll be using initialization vector is nothing but we have some, before this CBC mode of operation, there will be a vector that will be generated. So that only will be used the next operations. So an IV is maintained for each key. Then we are having sequence numbers. So each party maintains separate sequence numbers for transmitted and received messages for each connection. So when a party sends or receives a chain cipher spec, the appropriate sequence number is set to 0. Then we are having state changes. So first there are two changes only. One is either in the operating state or in the other one is called as the pending state. So operating state is nothing but something which is currently working is called as operating state. So pending state is state to be used. So that is built using the current state. So we'll be always moving from the pending state to the operating state. So we are having a party A, party B, client or a server or client. So the sending part of the pending state is copied into the sending part of the operating state. So from the pending, we copy to the operating state. So likewise, the receiving part of the pending state is copied into the receiving part of the operating state. So when it will be the last message when the handshake is completed. So this is basically called as your chain cipher spec message that will be exchanged between the two entities. Now coming to the SSL record protocol services. So SSL record protocol basically provides two types of services. One is called as your message integrity and the other one is your confidentiality. So we know message integrity means that the message should be secure. It should not be tampered or altered in between. So for that purpose, we are using a MAC with the shared secret key. It is similar to your HMAC but with different padding. So likewise for confidentiality, we are using a symmetric encryption with the shared secret key defined by the handshake protocol. We know symmetric encryption means for encryption and decryption, we'll be using the same key. That is called as a symmetric encryption. So it supports a wide range of protocols. So the one thing is message is compressed before the encryption. So now coming to the SSL record protocol operation. So record protocol operation. So by looking at the block diagram, you can understand the operation. So first, you have an application data. So the first step in the record protocol operation is fragmentation. So a huge byte of data will be divided into blocks. So each block size will be 2 power 14. So after fragmentation, the data will be compressed and after compression, we'll be adding the MAC and after adding the MAC, we do the encryption of the data and on top of that, we'll add the SSL record header. So this is how your SSL record protocol operation will happen. So now let us see one by one what will happen. So the record protocol basically takes an application message to be transmitted, fragments the data into blocks, compresses the data, applies the MAC, encrypt and add an header. So fragmentation. So fragmentation, as I already told you, the plain text will be divided into 2 power 14 bytes or less. So compression means all the records are compressed using the compression algorithm. So the plain text will be converted into a compressed structure. After that, they compute a MAC. So all the records are protected using the encryption, and a MAC algorithms defined in the current cypherspec. A shared secret key will be used for this computation. Then we are having null or standard stream cipher. So stream ciphers will be converting the compressed fragment structures to and from the stream SSL ciphertext. Then we are also having the block cipher. So for block ciphers such as DES, the encryption and MAC functions convert the compressed fragment structure to and from the SSL ciphertext fragment structures. And then we are having the record header, so where we'll be adding the SSL header. So this is the diagrammatic representation of how the data will be processed. So we are having an application layer data. So first fragmentation will be done. So fragment basically will be having the SSL plain text will be having the type, version and length. And then we do the compression of the data. So after compression, we are having the message authentication and encryption where we are adding padding, like we'll be adding the MAC, and in case if we need, we'll be also adding the padding. Okay, and then it will be passed to the next phases. So coming to the next SSL protocol, it is called as your SSL record format. The SSL record format, basically you have various parameters of fields. So the first field in a record format basically has a content type, where next we are having a major version, then minor version, then we are having the compressed length, then we are having the plain text that is optionally compressed, and then we have the MAC. MAC can be 0, 16 or 20 bytes. So all these are in encrypted format. So coming to the header, so header is nothing but the higher level protocol that is used to process the enclosed fragment. So what are the possible types of messages? Either you can have a chain cypherspec message, alert message, handshake or application data. So that will be basically specified in the type. Then version is basically current version is 3, then length, compressed length. So length of the enclosed fragment or compressed fragment. So what can be the maximum value? So the maximum value can be 2 power 14 bytes plus 2048. Okay, that is the maximum length. So coming to MAC. So how is this MAC calculated? So we have seen MAC is 0, 16 or 20 bytes. So MAC is basically calculated using, so first we'll be finding the hash of MAC, write secret, you append it with the pad 1, then sequence number, type, length, fragment, and this again will be appended with the hash of MAC write secret of pad 2, then it will be appended with the value that you are getting here. Okay, similar to HMAC, but the pads are concatenated here. So it can support two types of hash functions. One is either it can go for an MD5 and SHA. In case if you are going for pad 1, so it is nothing but the value, it is a hexadecimal value, 0 into 36 repeated 48 times if it is for MD5 or 40 times for SHA-1. So pad 2 means it will be repeated 48 times for MD5 or 40 times for SHA-1. This particular value, pi c. So what is the encryption? What are the various types of algorithms that support? So in block cipher means it can support RC2, DES, triple DES, IDF, Fortesa. In case if it's a stream cipher, we can either go for RC4, either it can be 40 or 128 bytes. So if a block cipher is used, then padding is applied. The last byte of the padding is nothing but the padding length. So coming to the next type of protocol is called as your alert protocol. So as I already told you, alert messages of two fields. So the first field will tell you whether it is a warning or a fatal message. The second field will tell you, in case if it is a fatal, what are the error messages that can be reported. So that can be an unexpected message, handshake failure, illegal parameter, decompression failure, likewise. So warning means something like which is a close notify, no certificate, bad certificate, certificate revoked, expired, all these are warning messages. So in case if there is a fatal message means the connection will be terminated and the session ID is invalidated. So no new connection can be established within this session. In case if it's a warning, it will just operate in even if it is a warning message. So next comes our SSL handshake protocol. So SSL handshake protocol basically it consists of the client and the server. So we can see a sequence of messages. There are four phases of messages that are being transmitted between the client and the server. So the phase one. So phase one means first from the client to the server there will be a client hello message. The server will be responding with the server hello. So here what will happen? Negotiation of the session ID, key exchange algorithm, MAC algorithm, encryption algorithm, and also exchange of the initial random numbers will happen in the phase 1. What about the phase 2? Phase 2, the server may send its certificate, server is sending the certificate and also the key exchange message. And it might request the client to send a certificate, that is certificate request it is sending. Server signals the end of the hello phase. So it will just give a message called server hello done. Now, after the server sends, the client has to send the certificate. In phase 3, the client sends the certificate if requested and may send an explicit certificate. It will send the client key exchange and certificate verify. This is another message. It can send an explicit certification verification message. Client always sends his key exchange message also. So once the phase 3 is completed, so the client will be sending a chain cipherspec. It will say it is finished. Likewise, the server also will send chain cipherspec finished. So chain cipherspec and finish handshake, that is the last message that will be exchanged between the client and the server. So we'll just see a demo of how this SSL handshake protocol works. So we'll be able to see a sequence of these messages. I'm going to use Wireshark for this packet capture. So randomly for our demo purpose, I'll be just opening a website like which is having an HTTPS secure website. And when I do the login process, I'll be able to see these types of messages. That is a sequence of um, messages that are exchanged in this handshake protocol. I will show you the demo. So coming to the cryptographic computations. So first, what do you mean by a pre-master secret? So if the key exchange is RSA based, it will be generated by the client. It will be sent to the server encrypted with the server's public RSA key. So in case if they are going for Diffie-Hellman, so we'll be using the pre-master secret where I'll be using the function g of xy mod p. So first, let us see what do you mean this pre-master secret. So the pre-master secret is the base for the remaining functions to get executed correctly. So pre-master secret will be calculated first, and after the pre-master secret is calculated only, we'll go to the master secret likewise. So coming to the master secret, it is a 48 bits, 48 bytes we have already seen. So master secret is basically MD5 pre-master secret. We are appending with the SHA-A. So A, B, B, C, C, all these are random values. It will be again appended with the pre-master secret, then with client random, with the server random. So first, what do you mean by this client random, server random? So client random and server random. So this is basically used in order to make the keys fresh. So this basically prevents the replay attack. So for that purpose only we are using this random keys. And then the next one is keys, MAC secrets, IDs. So the equation for this is MD5 master secret. We are appending with the SHA-A master secret, appending with the client random, then server random. So likewise, we are having for these are this A, BB and CC are nothing but the labels that are used. Okay. So finally, we'll be generating the key block. So the key block basically contains the client write MAC secret, server write MAC secret, we having the client write key, server write key. So what do you mean by client write MAC secret? I think we have already seen. It is used to create MAC for the client to the server data. Okay, likewise server write means from the server to the client data. What do you mean by client write key? It is an encryption key for the client data. Okay, server write means it is an encryption key for the server data. So why are we using MD5 and SHA here? Basically, so MD5 and SHA, they basically use different internal block sizes in SSL MAC design. So why we are using this is basically to detect any tampering and also to authenticate the sender. So that is the main idea we are going for these two algorithms, namely MD5 and SHA. So it's time for demo. So for demo purpose, as I already told you, I'll be using basically a Wireshark tool. So Wireshark you can easily install. Okay. So after you install, you'll be able to, once you install, it is a pretty simple. Just you have to click install. So once you click the install, you will be having various icons like file, edit, view, go, capture, analyze, etc. So you have to go to capture. So in capture, you have the options of where you want to do the capture. In case if you're connected to the internet, a local area connection, you can choose local area connection. Since I am using a Wi-Fi connection, I have just selected Bluetooth here. And then you have to give the start. So I'm starting the connection, and parallelly I'm going to open. I'm just typing https udemy.com where I want to log in. Okay. So I have logged in. So now I'll just go and stop this red icon. If you click means it will stop. So now this is how your packets that are being exchanged in a Wi-Fi network. Since I'm connected to a Wi-Fi network, you can see there are a lot of data that is going in and out of the network. So first there is some TLS. Now let us see our data. So you have to just scroll down. See here, I have just typed udemy.com. Okay, so first when I type udemy.com, there is a DNS protocol. So you know what is the meaning of DNS? So DNS stands for your domain name system. So first, this udemy.com should be converted into some form of IP address. So for that purpose, first our request goes and hits the DNS server, and once it hits the DNS server, our request will be converted into IP address. Okay, so after getting the IP address, then again request will go from my PC to that IP address. See here, it has found out the IP address to be 104. It's called in DNS we have various types of records like A record, MX record, AAA record, etc. CNAME record and all. So A is nothing but the um, address. So the address is 104.16.142 to 37. So this is my PC address 192.168.0.6. I'm going and hitting the Udemy server. So this is basically a TCP packet. So there is a TCP connection establishment that is happening here. So a TCP connection establishment means we know there will be a SYN packet, SYNAC and ACK that will be passed. So these are the three packets that will be sent in case if it is a TCP connection. Okay, so after the TCP connection is established, I'm sending a client hello message. So we remember the SSL um, handshake protocol that we have seen, a client hello. So here you can see if you expand. So this is the Actually, we are talking about the OSI layers, right? So here, this is a frame. This is a layer 2. This is your IP header. This is your TCP header, and this is your um, TLS. So here you can see it is a client hello message. The content type is handshake. We are having version as 1. Then there is a length. And then in the handshake protocol, we are having the client hello. So the length is 1949. So it tells the TLS version. There is some random sequence that is generated. We are having the session ID, then cipher suit. So there are 16 different possible type cipher suits that can be chose. It is telling the compression method, then reserved, etc., etc. So there are a lot of extensions that can be done. So typically, I think you'll be using TLS AES. Okay, so you have various options here. TLS with RSA, RSA with AES, likewise. Okay, so I'm just closing this. So after there is a client hello. Okay, so we have seen a client hello. Then there is a change cipher spec happening. So let us see, there will be a change cyberspec from the client side. Okay. So here change cyberspec, content type, version, length. It is telling the change cyberspec message. Then we are looking at the record layer application data. It is basically HTTP over TLS. So here it is telling the data is application data. It is telling TLS version is 1.2. The length of the message is 53. And it is telling the application data. Okay, once the client hello is done, then change spec application data is done. So likewise, the server will also be sending the server hello. Okay, so if you just expand it, here you can see it's the server hello. Uh, the length is the version, random, session ID, change cipher suit. So here you can see it has chosen TLS AES 128, GCM SHA 256. The compression method is null. The extension length, it is also telling the pre-shared key shared, supported versions, and change cipher spec. Okay. So this is what it will be exchange between the client and the server. Since there are many other data also that is passing in and out of the network, you can see other things. Other thing is that you can best to do is you can filter it based on protocol. So if you're filtering it based on protocol, you will be able to see the sequence of data that is transmitting. So likewise, you can see a client hello, server hello, likewise, you can just scroll and you can identify what are the types of data that are being exchanged between the client and the server. So the main idea of this packet capture is you can just see a TCP connection establishment happening, then you can see a client hello happening, then a server hello happening, change cipher spec happening, and then again change cipher spec from the other end also that completes the handshake protocol between the client and the server. So in case this is your TLS, okay, upper protocol. In case if you want to see a transport layer data also, TCP data, so each layer you can see what protocol it is using in the upper layer. So for example, it is a network layer. Network layer, we are seeing it is an IP protocol. So in IP protocol, it will say it is using TCP protocol in the next layer. Okay, in the TCP layer, here you can go and see it is using 443. So 443 means it is your secure HTTPS. So that is what each and every layer will be pushing the data correctly to the next protocol. So here we are able to see the chain cybersec protocol and also the HTTP over TLS. It is showing the encrypted data. Our data that we are sending, it will be in the form of encrypted data. So in case if you're not using SSL, if you're using a HTTP, normal HTTP protocol, you'll be able to see the password that you are typing in here. So the data will not be encrypted. The data will be in plain text. So if I will try to put one more video. where I will be using a server. For example, let us take any HTTP website. There are only minimum some test websites are there. So where if you just click on that HTTP website and you type the username password, here when you're doing a packet capture, you will be able to see the username password in plain text. So that is the main reason why we are going for HTTPS. So which means where our data will be encrypted and also no tampering will be done while we are going for these types of secure protocols. Okay, so I think you are able to have some more understanding of what exactly happens in this SSL protocol. So meet you again in another interesting topic. So meanwhile, you just keep practicing this. Okay, thank you. Thank you for watching this video.